Hello, this is the second video in our Bally sound card series. In the first video in the series, I explained our desire to build our own sound card for a Bally pinball machine so that we could inject our own sounds. To facilitate my understanding of how Bally managed to use the same lines to do both sound and solenoids, I built this little 6-line datascope that I could use to capture the interactions, and it could capture up to about 50 seconds worth of data transactions, and I demonstrated that to you in the last video. So in this video I want to just continue on where we left off and show you how I used Visual Studio and particularly the chart control in Visual Studio to build a quick visualization capability that would let me see those transactions and figure out exactly what they were doing. So that's what we're going to do in this video, so let's dive right in. So just as a reminder of where we were last time, this is one of the files I showed you, and I can use my cursor to click into some transaction, and then I can zoom in on that and see what it looks like, and if it drifts away I can click again to recenter it, and I can keep zooming in. That was that little bug I mentioned last time where it looked like the data wrapped. I don't know why that happens. So I just went there, and then I can right click to set my second cursor, and I can look and see that that's about a 9.5 microsecond gap from the time the data line set until the strobe sets. Or I can reset my first cursor at the beginning of the strobe and my second cursor at the end of the strobe and see that the strobe is 121 microseconds long. So nice and easy. Now, all of this is done in Visual Studios. I'm running 2022, and let me just move this out of the way. And I am using Visual Basic just because it's so freaking easy. So my form design looks like this, and this is the layout that Charts gives you. It gives you some default stuff when you first set it up. That's not real. That's just to give you a representation of what that chart looks like. I'll quickly point out the elements, if you will. This white area right here is the chart itself, and it's a chart control, and it's loaded up off of the toolbar. But there's something that I didn't know, and took me a whole day to figure out what was going on. I'll show it to you in a minute. Thanks to the web, I found the answer. Anyway, the rest of these things are just text boxes, you know, buttons and labels to show me what I'm doing. So let me stop the running of the debug so we can see how this is set up. If you look at the toolbox and scan down to data, you will see chart control, and by pulling one of these chart controls into your document, you can set it up to display the data that you want to display. However, chart is not supported under all the versions of .NET. And this is what I didn't realize. You have to be using .NET Framework in order for chart to work. So that's the old original .NET Framework that's been around for, I don't know, 15 years or something like that. They have not implemented it yet in the new versions of .NET, or I'm not sure what they're all called, but anyway, when I installed Visual Studio 2022, the default is not to use the old .NET framework, but to use the new .NET, and Chart wasn't there. And after some extensive searching on the web, I found out that you had to use the .NET framework. So once I did that, Chart showed up. I could add it to the capability, and that allowed me to do my display the way I wanted it to. So that was the one little trick. Once I got over that, the rest was relatively simple. Let's jump over and take a look at the code. And actually, probably before we look at the code, we should look at the data file that my datascope creates, so that we can understand what this program is reading. So here I just opened this up in Notepad. It's done in text. So the very first line of the file is going to be the word start, followed by the millisecond time tag in the microprocessor when it started recording. And then it's going to be a repetition of lines with 8 data elements on it. And this continues on down for a total of 26,000 records. And that is strictly based on the amount of memory I had in my microprocessor to store this data in before I had to dump it. Then I follow that with a stop and the milliseconds time that the microprocessor had when I stopped it, and then a total sample count. Now, let me go back up to the top. So the format of each of these lines is a D to indicate data, a starting number for what the count of this data element is, and then a 16-bit data element in hex. So it goes from, it could be 0000 up to FFFF. The right-hand 6 bits of these 16 bits of data are the bits that you input on the line, and the upper 10 bits is a repeat count. And I mentioned this in the last video also, is as I'm inputting data as quick as I can. Boom, 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 boom. As quick as I can go through the loop to pick up the data, I will record it. If the data is the same as the previous data, I just bump up this count. So this count can go up to 0 to 1023. And 0 is actually a 1 because you're always going to have at least one sample. So if the count is all zeros, that means you have one count. If the count is all ones, that means you have 1024 counts. And then I just put 8 of these on a line, just because that's faster than printing out a full line for each one. It's quicker to print, and it doesn't use up as many characters because you're only putting the count on once for every 8. So then I just go through and I dump that, and you can kind of see the data stays for a long, long time in exactly the same configuration. It's not changing at all. But eventually, as I start getting data in, you will see the data does change. I probably should have looked beforehand where this happened. Oh, there you go. So you can see right in here the data is changing from that FFDE that it was getting before. So this is the file that this code is going to read. And so I set up a couple of things beforehand. First, I set up an array with 26,000 locations in it. That's one for each of those data elements that's going to be in this file. All files are going to be configured the same. So they're always going to have 26,000 lines in them. And if I change that, I'll have to change this code to match. And then it has two elements. And as I read that in, I'm going to break it up into the data and the count. So now, you notice that I had a very bunch of repetition of the exact same count. So in my code, the next thing I'm going to do is scan through, and I'm going to compress this data down even farther by making a gigantic count and have one transition for each data element. So I will count, let me go back to that form. So as you can see here, the very first element is always 0. So that one's going to stand by itself. And then from this FFDE all the way down to wherever that change first occurred, and I might miss one here, but so someplace down in here, the data starts changing. Back up a little bit. So anyway, wherever it is, so all of that data, I'm going to compress all of that data into a single element, and I'm going to add up all those counts. And I'm going to put that into this compressed data array. Now, I initially just define it as one element long and 8 bits. The other thing I do is I'm going to break apart each of those data bits into individual bits so that I can graph each bit independently. And this is going to be the driver for the graph. So once I get this data into this thing, I'm going to dump it to the graph. And then I've got a bunch of other, starts and stops and things like that that I use in the program. So on my farm, the load log file will bring you to this button one click. I know I should have renamed that, but I'm lazy, so I didn't. So the first thing I do is a resetting of all of the variables that I use while I process the data file in. The compressed data array gets redimensioned to the size I need to hold the amount of data. These are, if you look here, it's a unsigned long data type, so that uses a lot of memory space, and I didn't want to chew up too much if I didn't need to, so I decided instead of trying to guess what it was going to be, I would just, when I process my actual data array, I will calculate how many locations I need, and I will redimension it to hold that data before I move it in there. So when I get done and I want to load up a new file, I need to redimension it back to that original 1x8 so that the rest of the stuff works right. So anyway, then I just click up a file dialog box asking what file do you want to open, and I open it and I do a try catch loop to bring in the data. So it either works or it fails, and right now I'm not going to do any more troubleshooting than that. If the line is start, I record the start time. If it's stop, I record the stop time. So if it's a D, I read the data into the data array. Remember, there's 8 elements here, so I got to run through this loop 8 times. And the first thing I do is I grab the data and I stick it into both the data and the count section. And for those of you who don't recognize it, this converts hex into an integer number. So I do that into the data side and the count side, and then I take that data and I AND it with either 3F, or I shift it over 6 places and AND it with 3FF. So that separates the data from the count. And then I increment my pointer P, and P is going to count as I fill in each location, and I will use P later on to redimension my other array so I can pack the data into it. And if the thing is the word total, then I record what the total iteration should be. And I use that and the start time and stop time to calculate the microseconds between sample times. And if for some reason the catch fails, I put out a chunky little error message that says I couldn't read the file, and it quits. Actually, I kind of spoke incorrectly earlier. I do not use the pointer P to figure out the compressed data array length. I use a thing called element count. So I set element count to 0, and then this little bit of code right here just scans through each locations to see how many different data types or data elements we have, and then I redimension the compressed array based on that element count. So next, I initialize the first location in the compressed data array with the first data type and data count. And then I run through a loop that compares the next data to the first data. And if they are the same, it just increments the count. If they are different, then it moves to the next location, and it just continues to repeat until it gets all the way down to the end. Okay, before we go into the next section here, let me pop back over to the chart to explain something. So since this is physically a chart, just like you would use in Excel or Word or something like that when you're creating a chart with data, you're going to display the elements across the line. Now I want this to look like a datascope. So each line will come across, and if there's a high, it'll jump up an amount and scan across, and then it'll drop back down when it goes back to 0. And I have 6 lines of that. So I need to place the lines at 6 different locations on the chart, and I need to make it go up and down if it gets a 1 or a 0. So since this index is numeric, I need to add an offset to each of the lines to make them higher up on the chart. And that's what this little section of code right here does. It starts off, it's going to go through the 6 data elements. It's going to start by taking the data and ANDing it with a 1. So there's 6 bits of data there. It's going to AND it with a 1, so it's going to get just the bottom bit. And that bit's either going to be a 0 or a 1. And then it's going to put that into the integer dd. And then it's going to multiply dd by 5. So if it was a 0, it'll be a 0. If it was a 1, it'll be a 5. And then it's going to add 12 times the loop count. The loop is 0 right now. So 12 times 0 is 0. It's going to add 0 to dd. And so in this first loop, dd will either be a 0 or a 5. And then it's going to store that back in the data array as that numeric value. And then it's going to shift the data over to the right one place. So now that's going to put bit 2 or 0, 1, we'll call bit 1. That's going to put bit 1 in the bit 0 location. It's going to run back through the loop. It's going to end it with a 1 again. And then it's going to multiply that by a 5. So it's going to be either 0 or 5. But then it's going to add 12 times 1 this time. So it's going to add 12 to that. So the second line is going to be 12 higher, and it's going to be going up and down 0 or 5. So the bottom line goes from 0 to 5. The second one goes from 12 to 17. And as it goes through the loop, each line gets raised up the same amount, and it stores that data back in the data array. So once that data has all been calculated, I have it all laid out real well. Now, I'm going to explain how I was really stupid when I first started doing this, and how I figured out that there was a way better way of doing it. So initially, I did all of this work of calculating all of this stuff beforehand, because when I displayed the data, I would clear my chart. I would figure out which bit of this data I wanted to display, and then I would write it out to the chart. Now, that was pretty good, except, like I mentioned, there's like 26 million data elements. So if I zoomed the chart out pretty far, I was writing a ton of data elements out there, and it got really, I mean, you know, take a whole lunch slow when I was getting all the way zoomed out really far. And then one day it occurred to me that this is a line chart. I don't need to show all the elements. I just need to show the starting element and the ending element, and the line is straight all the way through, and the chart will draw it straight. So I don't need to put in a million intervening elements of all the same number. It doesn't add any value to the chart, doesn't change a thing. So I rewrote the program so that it would just put the data out when it changed and the index location of where it changed. And I can now display all the data at once. So I went through a lot of work here to do all of this stuff, and I could clean that all up and do it all at once as I'm calculating the data and just put the points out, and it would be a lot smoother. But I've done it this way. It works already, so I'm not changing it. So once I get done with all that, then I go to initialize my display. And as you can see, that's a pretty simple little bit of doing. I just go through the array for the number of counts I have, adding points for each of the entities to the graph, and then I display it. That's it. It's that easy. The datascope stuff really takes care of itself. Sorry, let me restate that. The chart takes care of displaying all the data. I don't have to. I just put the data into the chart, and it's a series of points, and you can have multiple series and stuff. I only have one, just the one data series. After I get done putting all of these elements into the chart, I go to a routine called display, which actually does the displaying of the stuff. And it's not a very significant routine. I don't remember where it's at, but there it is. That's it. So it just sets the minimum and the maximum area to be displayed. and then the chart will automatically zoom in or out on that area. And this is why I was saying that that little wrapping of the data isn't my bug, because all I'm doing is giving it its starting and ending location to display, and it's for some reason wrapping that data. So here's where I was showing the initializing of the original display. And this is where I put all the data in, and that's once I've got all the data in, I don't have to load any more data ever. I'm just changing to zooming in and out. And I do that, let me jump back to my form for a second. These buttons right here that do the X in the middle is basically zoom extent. It'll zoom all the way back out as far as you can zoom out. And then this is move to the left, move to the right, zoom out, and zoom in. When I'm using the datascope to display the data I've captured, these 5 buttons allow me to zoom in and out, zoom extent, or shift to the left or shift to the right to see what particular data I want to see. In addition to that, I can click my left mouse button to pick a cursor, and that cursor will automatically get centered in the center of the screen. And when I zoom in or out, it'll zoom in or out on that cursor location. So to accomplish this in the code, I have a few routines here. And so pretty much all these routines are doing is establishing the starting point and the length of what I want to display, and the chart control takes care of all the rest of that displaying action. So if you look on the pan left, it sets the chart start to the chart length. It takes the current start chart and subtracts a quarter of the chart length from it. So it moves the chart to the left a quarter of a chart. And then it redisplays that. If I hit the zoom extents button, it sets the chart start to 0 and sets the length to the maximum length of all the data of things I have captured, and it displays that. The zoom double click is the zoom out function basically. And you can see it takes the chart length and multiplies it by 2. And then it calculates the start as the cursor location times half of the chart length. So it centers the chart around the cursor location, and it displays that. Zoom half does just the opposite. It divides the chart length by half and then centers that around the cursor location. And pan right, of course, is the opposite of pan left, where it just adds a quarter of the chart length instead of subtracting it. So before I show you how the cursor is done, I want to show you a little thing just so you understand. And I'm going to come in here and I'm going to actually run this again. So I'll start the debugger up. I'll load my data file, which is on my desktop. Okay, so there is my my data file. Now when I click on my cursor with my left button, it sets the cursor. You'll notice that the line goes from the bottom of the chart to the top of the chart, and that's it. And now when I start zooming in, whoops, I'm zooming out. When I start zooming in, I can recenter by clicking there, and I can keep going in, keep getting closer and closer. Now when I right click and set the green cursor, that's really not a cursor. it kind of looks like the cursor, but you'll notice it goes farther. It goes all the way down and goes all the way up. It completely goes from the top to the bottom of the display area. And this is called an annotation in a chart. So the red thing is actually a cursor, and the green thing is an annotation. Now, I didn't know anything about annotations when I put the cursor in. You can't have two cursors, but you can have as many annotations as you want. So probably if I had done this and I knew better, I would have a red and a green annotation so they looked alike. But anyway, it might get a little bit confusing when I start looking at the code, because in one place I'm putting annotations in, and in another place I'm putting cursors in, and they work just a tad bit different. Not much, but so I'm going to stop this. I'm going to go back to my code, and I'm going to look at the mouse down. So if you click either the left or right mouse button, you will come to this routine. And if it is the left mouse button, you're putting the red cursor down. If it's the right mouse button, you're putting the green annotation down. So if it's the left mouse button, if E dot button is the left mouse button, then you're going to set the cursor's pixel position to the XY position of the cursor on your chart. You're going to set I'm setting the line width to 2 just to make the cursor a little bit thicker and easier to see. So remember that when I click and put the cursor down, I want that to be the new center of my chart. So I take the cursor location and half of the chart length, and I set that to the new start. And so half of the chart will be in front of that cursor, half of the chart will be behind the cursor, and that'll have centered it, and then I'll do the display. If it is not the left mouse button, then I assume it's the right mouse button. I guess actually clicking the wheel would probably do the same thing in this case, since it's just a plain else. But I go set a new vertical annotation, and that code is actually just right down below here. And again, I just copied this from the web where somebody had done it. And so I create V3 as a new line annotation, and then I set its parameters, its X and Y locations, and its width and its color, and then I display that. So, and then this little chunk of code right here is setting up these cursor location and the difference things, so it can show you how far you are from the red cursor. And that's pretty much it. I do a little resizing thing. If I resize the form, I set the panel width and height. And excuse my dog barking in the background there. But that is pretty much all of the code. This little chunk, I didn't show this the first time through, but when you're setting up the chart, this is where you load each of the data elements into the series. There are dozens and dozens and dozens of YouTube videos that do a far better job than I could ever do in explaining how to use charts and how to load data and stuff like that. So, you know, if you want to ever do a chart thing like this, go watch the other videos where they are actually teaching you how to build a chart, and then you can go from there. So that's going to be it for this video. It's just a short little video showing you the code and the chart capability that's built into Visual Studio that lets me display this data with hardly any work on my part at all. Thanks for watching. The next video will probably be on the datascope itself and the code that captures this data, and since the first video, I've built two new test components. They're both built on little STM32 microprocessors. One of them will capture the lines and show what sound is being played. And the other one will generate sounds. It will put the codes out for a sound and play them, so I can play all of the sounds in order, starting with 0 and running up to 31, so that I can record that information. Maybe I can wrap all of that into one video, and then probably the video after that will be the actual sound card I build that puts all of this stuff together, along with a little MKR0, Arduino MKR0, I believe it is, which is an Arduino with an SD card reader on it and a support for I2S, which is the audio protocol. So using that little chip, I can read data off of an SD card, which will be sound file data, and send it out via I2S to an I2S DAC that will convert that into the actual sound. So it'll start getting interesting once we get down to that point. I know this coding is really crap and it's not very interesting, but it's gonna get a lot more interesting, I promise you. So again, thanks for watching. Like and subscribe if you care to. Don't if you don't. Doesn't really make too much difference to me, but anyway, I like the feedback. You guys have a great day.